Climate change is caused by greenhouse gases, and while the most important greenhouse gas is of course CO2, just because there's so much of it, there are many other greenhouse gases that contribute to global warming. And from all these greenhouse gases, the most potent greenhouse gas at all is called sulfur hexafluoride, or short SF6. There's no other greenhouse gas that has a higher so-called global warming potential, which means how much it contributes to climate change per ton or per kilo, than SF6. It has been known for a while that something doesn't really add up when looking at SF6 emissions. There are reports from countries where they report how much they think that they emit of this gas, and there are measurements from scientists that regularly show higher emissions of this gas. And recently, a team of researchers led by researchers from the Goethe University in Frankfurt in Germany have apparently found a source of SF6 that was not previously known and that probably contributes to these inconsistencies between measurements and official statistics. If you put 1 ton of SF6 into the atmosphere, its effect over 100 years is as bad as putting 25,000 tons of CO2 into the atmosphere. This is the so-called global warming potential. And there's no other known gas that has a higher global warming potential than SF6. And this has been known for quite a long time. For example, in 1995, the second IPCC report was published, which summarizes the knowledge about climate change. And even back then, they listed a global warming potential of 23,900 for SF6, which is pretty close to the current estimates. So we have known for decades that SF6 is a very strong greenhouse gas. But SF6 is also very useful. It was or is used in many applications in different industries, and in some things you might not expect it. For example, Nike used to put SF6 into the soles of its so-called Air shoes. That was highlighted in the early 90s by apparently a German magazine, but they continued doing that for many more years until in 2006 they announced they had eventually replaced it with other less harmful gases. Today, many uses of SF6 have been restricted or banned, particularly in the European Union. They have the so-called F-gas regulation, which regulates the use of many of these very potent greenhouse gases. So you would no longer be able to find a shoe, or, for example, it has also been used in windows. That is all no longer allowed here. But that does not mean that SF6 has completely disappeared. One use case where SF6 is still very common is in electric switchgear, particularly in high voltage electric switches, the ones that are used, for example, to connect a power plant to a grid, or that is used in an electric substation. One of the reasons for that is that SF6 has an especially powerful property that is to prevent electric arcs. As you can imagine, in electric equipment, you don't want electricity to jump over from one place to another and create what is essentially artificial lightning. You want to prevent that, and SF6 is apparently particularly good at doing that. And that is also the reason why it's still very common, and probably also a main reason why it hasn't been entirely banned until now. But even in the switchgear, change is coming. This was also in part due to a push from industry. There was an open letter from various manufacturers of such electric equipment, and as you can see, this includes well-known names like Siemens or Toshiba. And they said, we no longer need this. We can build these switches without resorting to SF6 and other so-called F-gases. This eventually also led to a regulation within the European Union that has the goal of phasing out SF6 over time. It will still be around probably for many decades. First of all, this is a long-term phase out. It's not from one day to another. And also there's a lot of existing infrastructure that uses SF6 that will be around for many decades to come. Okay, now going back to this recent research. There is something called the Advanced Global Atmospheric Gases Experiment, or short AGAGE, which is an international collaboration of researchers and measuring stations that look at greenhouse gases and other gases in the atmosphere. This is a graphic not about SF6, this is about another gas, so-called CFC11. CFCs are the so-called chlorofluorocarbons. Those have mostly been banned because they damage the ozone layer, which protects us from ultraviolet radiation from the sun. If you emit too much of these gases, you have more skin cancer on Earth. Due to that, it has mostly been banned. As you can see here, the concentration in the atmosphere has been going down over time due to this ban of these gases. In 2018, these researchers found that the concentration of this CFC11 was not going down as fast as they would expect. They were able to figure out that there must be sources of this gas that were probably from China, and that turned out to be true. This led to the discovery of essentially illegal production sites of this CFC11. Actually, the Chinese government reacted very aggressively on that. There's a report that they have submitted to the United Nations, which I will also link in the description. They are reporting that after they learned about this, they have identified and destroyed multiple illegal production facilities for this CFC11 gas. This story brings us back to the SF6 because this success in identifying sources of emissions that were not previously known led to eventually this research that identified this SF6 emission source. This is the Taunus Observatory, which is near Frankfurt in Germany, and which is also part of this international science network of atmospheric measurement stations. A couple of years ago, the scientists working there noticed that they had regular events where there was much more SF6 than they would usually expect. Apparently it came from the southern side, so they had some idea from which direction it was coming from. Together with other measuring stations, they were eventually able to limit the area where they knew that these emissions had to come from. They published their findings in November, and they didn't mention a specific facility in there, but they do mention that within that area the only European production site for SF6 is located. Shortly after that, there were various media reports. This was started by investigations by Spiegel, which is a big German weekly magazine, and ZDF, which is a public broadcasting station. They published articles about this research and also mentioned that this almost certainly comes from a factory that is operated by the chemical company Solvay. Solvay operates a chemical plant which is in Bad Wimpfen, which is a small town in southern Germany. And apparently that is also the only SF6 production site anywhere nearby. This factory has a bit of a history of controversies. While researching this, I learned that already in 1990 there was a Greenpeace protest against this factory because back then they were producing CFCs, which are these gases damaging the ozone layer, and halons, which are other gases that are damaging the ozone layer. Today they are all banned and they are no longer produced there. More recently, there was another controversy around this factory. They were releasing TFA, which is one of the so-called forever chemicals, or PFAS, into the river. And that was, as they always maintained, completely legal, but it was still very controversial. And they have recently announced that they will stop these releases of TFA into the river in 2026. They kind of just came out of this other controversy, and now they have this SF6 issue. From this research, the scientists estimate that there's an emission source that emits around 30 tons of SF6. That is completely unexpected because what they have officially reported was that they only emit 56 kilograms. That was in 2023. These estimated emissions are around 500 times higher than what they had reported. Recently, it was also confirmed by local authorities. There was a press release from the Ministry of the Environment and the local regional government. They seem to be now in a bit of a legal dispute with the company because the regional government has ordered the company to both lower their emissions and also to measure them, and the company is now legally challenging those orders. We will see how that ends. One more thing I wanted to show is I said that they reported 56 kilograms of emissions in 2023, but I looked at what they had reported before. Due to regulation by the European Union, every company operating within the EU has to report its emissions to public databases, and everyone can access these databases. So you can download that data from the German Environmental Agency and have a look at it. This is how this data looks. There are some things that are quite unusual. There are two gaps in the data. For 2 years, there's no emission data at all. There is an explanation for that, and the reason is that there's a threshold of 50 kilograms for SF6. If you have less than 50 kilograms of SF6 emissions, then you don't have to report it. But also, as you can see, for many years, they reported exactly the same value from 2014 to 2022. It's always 60 kilograms, except for this years with the gaps. And this obviously doesn't look very plausible. As we know now, this data is completely incorrect because the emissions are much higher. But just looking at this reporting, it seems something was not plausible here before. I learned from the Environmental Agency this data is not yet public, but in 2024, they reported 310 kilograms, which is much higher than before, but it's still much, much lower than the 30 tons that these researchers estimate. At that point, they probably knew about that because there have been conversations between these researchers and the authorities and the company, at least since 2023. It's a bit unclear why they still report these low emissions when they must have known that they are much higher. If you found this interesting, I would appreciate if you like this video and if you subscribe to this channel. I also wrote about it and I have more details in there, and I will put a link to that article in the description. I'm also thinking about making kind of a series about lesser known greenhouse gases. If you find that interesting, please leave a comment and I may do that in the future.